The web evolves and grows over time as new content is created, modified, and removed. Entire websites can emerge overnight. New web pages appear and disappear every second, and content on a page can change at every instant. Current access to the web, however, remains limited to a snapshot at a particular moment. When a user visits a web page, he cannot see whether and how its content has changed. All he can see is the most recent version of that web page. Some websites provide temporal context, such as sites on polling statistics and stock prices, but this data can be difficult to analyze and integrate with content from other websites. This lack of access to content over time limits the kinds of questions users can ask on the web. We present Zoetrope, a system for manipulating the web over time. Zoetrope allows the user to easily look back through previous versions of web pages and generate visualizations and extractions of this temporal data. With our system, the user can track the price of an item or the rating of a favorite movie. He can track headlines and monitor topics of interest, such as the environment or politics. The user can also investigate relationships between different websites and answer questions such as, what is the relationship between gas prices and oil prices? Or how do headlines differ between sources? And he can do so from the comfortable context of the web pages he sees every day. Let's follow this user as she uses our system. Sally drives a lot, and she's spending more and more money on gas. She goes to gasbuddy.com in order to learn more about the topic. With Zoetrope, Sally can scroll back in time and view the whole page just as it appeared yesterday or last week. Sally can also place a time lens over any part of the web page and scroll just that part of the page. She can place any number of lenses on a page. She can also bind two lenses together and scroll them synchronously. Different lenses enable different types of behaviors. With a DOM lens, Sally can isolate specific web page elements, such as the average gas price. She can view the price changes in context, or she can create a visualization. There's an unusual peak on May 22nd. Sally loads up CNN.com to see if there's a similar peak in oil prices. She uses another DOM lens to graph oil prices. To explore the two data sets together, Sally binds the two lenses and explores the graphs in concert. There's a strange dip in oil prices at the same time that gas prices rise. Next, Sally loads a news aggregator to see if there are articles that might be related to these fluctuations. To look for articles on a specific topic, Sally uses another lens and specifies a topic of interest, in this case war. She binds the new lens to the CNN lens and can now browse the headlines using the graphs. Sally finds that around this same time, Congress passed a bill on Iraq spending. She hypothesizes that this may have been the cause for the fluctuation. Our system can be used to accomplish a variety of goals. In this example, the user is looking to buy a DVD and is interested in getting a good price. Since there are many shoppers and sellers at Amazon, the price fluctuates a lot. She places a lens on the price and graphs it over time to see whether she should buy today. Business analysts can also take advantage of our tools to track competitors and look for trends. Here the user collects stories about Google from CBC and CNN. News stories can be viewed on a timeline, showing the story's lifespan and evolution, and visualizing how fast new stories emerge. There's a variety of scientific data on the web. With Zoetrope, scientists can collect data from different sources and integrate their findings. Here the user is looking at seismic activity over time. In this example, the user is looking at traffic conditions. She places a location-based time lens over the highways of interest and scrolls back, looking at past conditions to see if things are getting better or worse. She filters with another lens to look at traffic conditions at 6 p.m. on previous days. Some days seem better than others. The user loads up the Yahoo Sports page to check if the bad traffic is related to game days. She binds the game lens to the traffic lens to see the relationship. She also opens the weather page to check if the bad traffic is related to bad weather. The user can also use the cluster visualization to see traffic maps according to weather conditions. We can export any lens data into other applications. Here we visualize price and volume data with Google Spreadsheet's motion chart. We have presented a system that enables users to manipulate temporal web content. Our contributions include a query language for accessing temporal web content, an indexing structure for processing queries quickly, and interaction techniques for accessing and viewing the web over time.